All right, fifth graders, before you finish watching the rest of this video, I would like you to get your virtual science experiment document in front of you. And I would like you to make a prediction on whether you think sugar will dissolve faster in hot or cold water. So go ahead and pause my video. And I gave you a sentence stem. So you can say, I predict sugar will dissolve faster in, you can put hot water or cold water here, and then give me a reason why. So you could say, because I've seen that this has happened in real life, or because I think hot water has more energy, whatever you think is the best way to go here. All right, so make your prediction. When you're done making your prediction, go ahead and unpause my video and we will continue onward. So this is the graded portion. So if you just watch this video, you're not doing your assignment. So make sure that you write down your prediction as well. So I'm going to go back here. Okay, so we're going to be watching a virtual science experiment with dissolving sugar into water. So we have cold water and hot water. We have sugar, we have a spoon and a stopwatch, and you just made your prediction on whether you think the sugar will dissolve faster in warm or cold water. Also, if you were at a Google Meets on Friday, you might already know the answer to this question, so I'm kind of ahead of the game here. So first, we're going to watch this little video.
By now, you probably know how to measure the length of something, or count the amount of money you have. But today, we are going to learn about 3 new types of measurement: mass, weight, and volume. Mass is the amount of matter in an object. If something is made up of matter, it has mass. So the mass, or amount of matter, of an elephant is going to be greater than the mass of a paperclip. We can measure mass using a tool called a pan balance. The units of measurement for mass are grams, abbreviated lowercase g, and kilograms, abbreviated lowercase kg. There are 1,000 grams in 1 kilogram. Weight is defined as the amount of the gravitational pull of an object. It is the measurement of a force. At home, you might use a digital scale to find your weight. We usually measure our weights in units called pounds, abbreviated lowercase lb. What you are actually doing when you weigh yourself is measuring the force of the gravity keeping you on Earth. Scientists also use a tool called a spring scale to measure weight, or the force of gravity on an object. To use a spring scale, you hold the scale upright and connect the hook to whatever object you want to measure. Spring scales measure items in units called newtons. In 1 pound, there are about 4.5 newtons. Finally, let us talk about volume. Volume is the amount of space something takes up, and we can measure the volume of solids, liquids, and gases. We can measure the volume of liquid in tools called beakers and graduated cylinders. We measure volume in units called milliliters and liters. There are 1,000 milliliters in 1 liter. The measurement marks on the graduated cylinder or beaker measure milliliters. If we want to measure how much juice is in our cup, we would pour it into a beaker or graduated cylinder and read the marking where the juice rises and stops. Now you know the difference between mass, weight, and volume.
All right, so there's that video. Now we're going to watch this inquiry rewind here. That's going to show us a little bit about this experiment. So, if it pulls up, that's the key here. Okay, so we're going to watch this experiment. There we go.
In this lesson, you'll take measurements and determine if mass is conserved after matter is mixed. Let's look back at the video you saw earlier in the lesson. How do you know that something is happening with the water and the tablet? In this activity, you'll investigate how temperature affects the ability of a solid to be dissolved into a liquid. To carry out this investigation, you'll use beakers, hot tap water, cold tap water, sugar, a spoon, and a stopwatch. To complete,
so fifth graders, if you do complete this experiment at your house and let me know that you did it, I will give you some bonus points. All you need is sugar and water. So if you have sugar and water at your house and you have something to time it, how long it takes to dissolve, I think that that would be something cool for you to do, and then show me a video of it when you are finished.
This activity, you'll dissolve sugar in hot water and then again in cold water. Before you begin, make a prediction. Will sugar dissolve faster in warm or cold water? Take a moment to record and share your prediction with your classmates. Then select Continue.
We've already done that, so we're going to skip ahead. If you haven't made your prediction, go back to this doc and predict if you will think which one will dissolve faster. So that's your first step. Make sure that you do that. And clicking Continue.
Pour 200 milliliters of hot tap water into a beaker. Now pour 200 milliliters of cold tap water into a second beaker. Next, use your spoon to place 2 level spoonfuls of sugar into the hot tap water.
All right, so they're putting the sugar
Start the
in there.
stopwatch and begin stirring the sugar into the hot water using the spoon. Stop the timer when the sugar has dissolved completely. It took 16 seconds for the sugar to completely dissolve in the hot tap water. In your data table, record the time it took the sugar to dissolve in hot water in the Time to Mix column.
So you don't have to record the data. I just want you to watch the experiment. So you don't have that table in front of you. That's okay.
To finish recording your data, select Next.
Done that.
Remove the spoon from the beaker of hot water. Measure the volume of hot water and sugar in the beaker. Record the volume for the hot water and sugar. When you finish recording the volume of the hot water,
So fifth graders, as you can see, it's still at 200 milliliters, even though we put sugar in it. So that means that the water didn't get bigger, even though we added something to it. So that means that the sugar completely dissolved into the water so much that the water didn't even increase in amount.
Record the. Now let's see what happens when you mix sugar into the cold water. Use your spoon to place 2 level spoonfuls of sugar into the cold tap water. Start the stopwatch and begin stirring the sugar into the cold water using the spoon. Stop the timer when the sugar has dissolved completely. It took 1 minute and 45 seconds for the sugar to completely dissolve in the cold tap.
So those of you that predicted that cold water would dissolve slower than hot water, you would be correct with your prediction. And then I think it's going to explain why.
Tap water. In your data table, record the time it took the sugar to dissolve in the cold water in the Time to Mix column. When you finish recording your data, select Next. Remove the spoon from the beaker of cold water. Measure the volume of cold water and sugar in the beaker. Record the volume for the cold water and sugar.
Looks like it's 200 milliliters.
What do you notice that is similar and different between the two beakers? Now that you've finished gathering information, take some time to of the community.
Okay, so what I want you to do, fifth graders, is I want you to go back and see if your prediction was correct. So you could say, my prediction was correct, or my prediction was incorrect. So if you predicted cold water, then you would have been incorrect. If you predicted hot water, then you would have been correct. So that is our virtual science experiment. Things do dissolve quicker in hot water, and that was what you're supposed to learn from that whole thing, because hot water has more energy in it. So kind of fun. Try it at home. Show me a video of you doing the experiment, and I can give you some extra bonus points for our party.